Hi everyone. In this class, we'll study the copying function in Python. Right. Now, assume that there's a class point which represents some point in two-dimensional. Then I will create one instance p1 of the class point. Then I will give the attribute values p1 dot x equal to 3, p1 dot y equals to 4. Then I will check the memory location to which the p1 is pointing. You can observe here 90935536 is the memory location to which my object p1 is pointing. Now what will happen if I use like this operation p2 equals to p1, right? So now you might be feeling that p1 is copied into p2. I will just check the type of p2. You can see here p2 is also belongs to the same class point, but p1 is not actually getting copied into p2. It is just an aliasing operation. Now if you check the id of p2, you can see here it is pointing to the same memory location as p1 was pointing. So now p2 is a complete aliasing for p1. So any changes in p1 could also reflect the changes in p2 also. So for example, p1 dot x, I will change it to 50, right? So now I will check the value for p2 dot x. So p2 dot x is 50. It means that any changes occurring to p1 will also affect the p2. So this equals to the aliasing operations. This aliasing can be pictorially viewed as this example. You can see here, this is class point. P1 is pointing to this memory location. Similarly, P2 is also pointing to the same memory location. P1 and P2 are referring to the same. But our intention is we want separate memory location for P1 and also we want separate memory locations for P2, so that any changes in P1 will not reflect the changes in P2. For this purpose, Python is having one module that is copy. So I'll just use that import copy. Now what I will do is P2 equals to call the module name, that is copy, dot inside that function name is again copy. What I want to copy? P1. Now we'll just check this operation. So now module name, I have imported the module copy. Then again module name dot function name. Module name is copy, dot function name is also copy, and I'm copying P1 to P2. Now just check the ID of P1, that is same 90935536. Now also check the ID of P2. You can observe here memory addresses for P1 and P2 are different. So when you use the copy function, you are actually creating the separate copy of the object P1 in P2. So I will just check any changes in P1 will affect in P2 or not. P1 dot x, what is the value? 50. So I will make it as now P2 dot x also I will check. So both are 50. Now what I will do? P1 dot x equal to I will make as 400. Right, P1 dot x, I will just print it is 400. Now check for P2 dot x. It is 50 only. It is unaffected. So this is how we perform the copy operations in Python. Now here, when I use the function copy with the model copy, it is going to create me a separate boxes or a memory locations for the objects. But whereas when I am using the equals to operator, it is just an aliasing operator. Both P1 and P2 refers to the same memory location if I am using equals to operator. Whereas if I am using copy operation, P1 and P2 refers to the different memory locations. So there are two types of copying in Python, that is shallow copy and deep copy. So before that, we'll just check with an example now. Here again same, I have considered the previous example, class point, P1 is the instance of point, two attributes x and y are given to the instance P1. Similarly, class rectangle is created, box 1 is an instance of the class rectangle, then its three attributes, width and height and corner. Width and height are of integer type, then corner is of point type, then I have given x and y, that is origin values I have given. So this is the classes I have created. So now what I will do is I will just import copy model. Then I will say box2 equals to copy. First copy is for a model name, that is copy. Second one is function. What I want to copy here, box1. So now box1 is copied into box2. So I have to check now whether these two are pointing to the different memory locations or same. If they refer to different memory locations, our copying is successful. If they are referring to the same memory location, then it is aliasing, right? So I'll just check ID of box1 is correct. Then I will check ID of box2. So both are referring to the different memory locations. So the copying function is successful. So now one challenging point is here is in the class rectangle, I am using one more class, that is point instance of, and one more class instance. So if I just check the print the values, right? So for example, box1 dot corner, right? Box1 dot corner dot x value, right? It is 0. Similarly, I will check box2 dot corner dot x, it is also 0. I will just try to change the value for box1. Box1 dot corner dot x equals to 20. Check for box2 now. Box2 dot corner dot x. Oh, you can see here value is 20. It means that any changes in the first object is also reflecting the changes in box2. It means that whenever you apply the copy function on any class, the function creates the different references, right? But embedded object instances are ignored. I will explain you pictorially. You can see here, this is what the scenario is now. So now this was box1. Box1 had separate memory location. Box2 also had separate memory location, but the embedded instance, that is corner, that embedded instance corner are referring to the same memory location point. I hope you are able to understand. Whenever you apply the copy function, right? If your class is having any embedded instance of another class, so the copy is not applied to that embedded instance. So this is shallow copy. This concept we call it as a shallow copy. So whenever you apply the copy function on a class which is having instances embedded from different class, right? Only those embedded instances are not created different memory locations. So this is shallow copy. But our objective is we want to create different memory locations even for the instances embedded in the class. In that time, we will use the deep copy concept. So now we'll just check the deep copy function now. So I hope you are clear. Whenever I use the copy function, it's a shallow copy. That is, it doesn't apply the copy to the embedded instances. Right now, instead of copy, I will just use here deep copy. Just check this. So now deep copy means even the embedded instances of different class will also get a copy function properties here. Just check here ID of box1, similarly ID of box2. Now just check box1 dot corner dot x, it is representing 20. Similarly now box2 dot corner dot x is 20. Now I will change the values for first object, it is box1 dot corner dot x equals to, I will make it as 40. I will just check the values for second object, box2 dot corner dot x. So it is 20 itself. For first object, box1 dot corner dot x. Okay, you can observe here for first object was changed, but the second object remains unchanged. So whenever I'm using the deep copy function, the copy is applied to the main class and also the instances embedded inside the main class. The instances might be of different class. I hope you're clear now. Shallow copy means when you are applying the shallow copy on any class, it applies to its attributes, but it doesn't apply to the instances of different class. So it will remain unchanged. Only aliasing will occur there. But when you apply the deep copy on the class, it applies to the main class and also the embedded instances of another class also.